Good morning, everyone. Yeah, good morning. So, shall we begin? Yeah, same. Today's topic is chapter number 2, that is the digital image fundamental. Same topic, continuation of the same. Yes. I- That is the electromagnetic spectrum. Okay. So, let's start with the chapter number 2, that is the digital image fundamentals. This is one of the line that says that those who wish to succeed must ask the right preliminary question. That is, he or she must have to or must have the right to ask for the, we can say the preliminary, we can say the advanced question that is prepared for the digital image fundamental, that is prepared for the digital images. Now, the purpose of this chapter is to introduce you to a number of the basic concepts in digital image processing that are used throughout the book. And this section summarizes the mechanics of human visual systems, including the image formation in the eye and its capability for brightness, adaptation, and the discrimination. So there are three parts for this one. One is brightness, then there is adaptation, and there is a discrimination for the concept for the usage that is used with the eye, that is used with the concept of the digital image. And this chapter includes each and everything that is used, that is available for the digital, or that is available for the basic concept in the digital image processing. Yes, this chapter also includes what are the various imaging sensors that is used in the image, that is available for the image creation. So that is, we can say that is available for the digital image creation. An additional topic that is discussed in this section that also includes the digital image representation, that is the effects of varying the number of the samples and the intensity levels in an image, and the concept of the spatial and the intensity resolution, and the principle of the image interpretation. And yeah, this also deals with a variety of the basic relationship between the pixels. And there are multiple mathematical tools that we use throughout the book. And the main objective is to developing a feel of how these tools or various tools, how the various tools are used and what are the scope of the tools, and how applications are expanded as needed in the remainder of the book, as required, we can say, in the remainder of the book. So first one is the elements of the visual perception. So what are the various elements, or we can say what are the various parts of the digital image processing. So that is built on a foundation of the mathematical and the probabilistic formulations, human intuition, and the analysis that plays a central role in the choice of one technique versus another. So whatever the role, whatever the intuition, whatever the analysis, that also plays a central role in the choice of one technique versus another, and this choice is often based on the subjective visual judgment, that is what are the various visual judgments that is required on the subjective part, that is required on the visual payment. And hence developing a basic understanding of the human visual perception as a first step in our journey, that is also available for this book, that is also available for this perception. And when we given the complexity of and breadth of this topic, we can only aspire to cover the most rudimentary aspects of the human vision that is acquired, that is used for the complexity and the breadth. And in particular, when we talk about the interest, that is the interest is in the mechanics and the parameter that is related to how the how different or how images are formed and perceived by the human. That is how the images and how the perceptions will be formed by the human errors. And we are interested in learning the physical limitations of the human vision in terms of the factor that is also used in the digital images, that is also used for the visual perceptions in the digital image. And therefore, thus the factors such as how human and electronic imaging devices compare in terms of the resolution and the ability to adapt to changes in the illumination, and not only we can say interesting, they are also the important from a practical point of view. So they are also important from a practical point of view, that is the visual perception. The next one is the structure of the human eye, that is how we can use, or there is a simplified horizontal cross section of the human eye that is also available, and this is nearly a sphere with an average diameter of approximately 20 mm. There's a this is the structure of the eye, that is human eye, that has a cornea, sclera, that outer cover, choroid, and the retina. And cornea is a tough transparent tissue that covers within this. So this is a cornea. This is the iris, then this is the ciliary muscle and ciliary body, then anterior chamber. These are the various lens that is used for to see anything. Then ciliary fibers, then visual axis, vitreous humor. This is the retina. This is the blind spot. If this is not okay, then there is a blind spot within the human being. That is a simplified diagram of a cross section of the human eye. The next one is a fovea. Fovea means part that is also used in the human eye. Then outer boundary, that is known as a sclera, and there's the choroid, which is the nerve and the sheath. That is the nerve and the sheath that is also available at the upper end, or the at the, we can say, the corners of the eye. So three membranes that is also used, or that is also enclosed within the eye. One is a cornea, one is a sclera, one is a choroid, and the retina. And the cornea is a tough transparent tissue. Where the cornea, this is a tough transparent tissue that covers the interior surface of the eye and continuous with the cornea. The sclera is an opaque membrane that encloses the remainder of the optic globe. That means it's the opaque membrane that also encloses the remainder of the optic globe, that is the sclera. And the choroid lies directly between the sclera, and this membrane contains a network of the blood vessels. That means blood is also available within this membrane only, and that also serves as a major source of the nutrition to the eye. And even when we talk about the superficial injury to the choroid, often not deemed serious, that can lead to the several eye damage. For example, if there is an inflammation, that also damages the eye, that restricts the blood flow. And the choroid coat is heavily pigmented and hence help to reduce the amount of the extraneous light entering the eye, and the back scatter within the optic globe. And at its interior extreme, the left choroid is also divided into ciliary body and the iris. When we talk about the central opening of the iris, that is the pupil, that varies in the diameter from approximately 2 to 8 mm. The front of the iris contains a visible pigmentation of the eye, whereas the back contains black pigment. So one is the front, that is also that contains the visual pigment of the eye, and the back. Yeah, when we talk about the diagram, this is the front and this is the eye. This is the front, this is the back. So the front of the iris contains a visible pigment of the eye, that is from which we can see, or that is used for the visible pigments, whereas the back contains a black pigment. One is a visible pigment of the eye, one is a black pigment. And the lens is made up of the concentric layers of the fibrous cells and is suspended by a fiber that attached to the ciliary body, that contains 60 to 70% water, about 6% fat, and more protein than any other tissues in the eye. The lens is colored by a slightly yellow pigmentation that increases with the age. So that automatically increases with the age, that is the lens that is covered by or colored by a slightly yellow pigmentation. And in most of the extreme cases, excessive clouding of the lens that is caused by the affiliations or affliction, commonly refers to as the cataracts or cataracts, that can lead to a poor color discrimination and loss of the clear vision. And the lens absorbs 8% or approximately 8% of the visible light spectrum, that relatively high absorption at a shorter wavelength. And when we talk about the both infrared and the ultraviolet light that are absorbed by the proteins within the lens structure and in excessive amount, that can damage the eye. So whenever there is a high, we can say, the infrared rays that is approaching to our eyes, that also damage, that is in the excess, that is excessive amount, that can also damage the eye. Now, when we talk about the innermost membrane of the eye, that is known as the retina, which lines the inside of the walls entire posterior positions. That means it is available within the posterior position, that is known as the retina, which lines the inside of the wall. That means it is available within the inline of the, that means it is available with the retina that goes or that lines the inside of the wall's entire posterior portion. And when the eye is properly focused, light from an object outside the eye is imaged on the retina. That means it is focused on the retina, it is available on the retina. And the pattern vision is afforded by the distribution of the discrete light receptors over the surface of the retina, and there are two classes of the receptors. Now, when we talk about the receptors, there are two classes of receptors. Now, where are the receptors? There are two parts of the receptors that, sorry, that is the cones and the rods. So there are two parts. One is the cones, one is the rod that is available for the receptor that is used to, we can say, the maintain the eye of the maintenance of the eye. Cones in each eye number between the 6 and the 7 million. So cones of each eye or cones in each eye number that range from the between the 6 and the 7 million, and they are located in the central portion of the retina. This is the central portion of the retina. This is available within this one. And at its anterior extreme, the choroid is divided into ciliary body and the iris. Then later, the latter contracts or expands to control the amount of light that enters the eye. The central opening of the iris varies in the diameter from approximately 2 to 8 mm, and the front of the iris contains the visible pigment of the eye, whereas the back contains the back pigment. This is done, we can see. So just do one thing, read only this part because 3 paragraphs are left for this one. So just read these paragraphs that we have covered. And when we talk about the lens, that is made up of the concentric layers of the fibrous cells that is used, and that is suspending by the fiber that is attached to the ciliary body. So that is attached with the ciliary body that contains, so that covers around 60 to 70% water, about 6% fat. So these are the various tools, these are the various lenses that is available. Now this lens is available, or that ranges from 60 to 70% water and about 6% of the fat and more proteins than any other tissues in the eye. Then the lens is also colored by a slightly yellow pigmentation that increases with the age. Automatically the lens will we can say the upgraded out automatically, or pigmentation will be increased automatically with the age of a person. And in the extreme cases, excessive clouding of the lens caused by the affliction, commonly referred to as cataracts, can lead to the poor color discrimination and the loss of the clear vision. That is available with the loss of the clear vision, and that can lead to the poor color discrimination. Then the lens also absorbs 8% of the visible light spectrum. This lens automatically, or this absorbs 8% of the light spectrum that is relatively high absorption at the shorter wavelength. And the both infrared and the ultraviolet light are absorbed by the proteins within the lens structure, and in excessive amounts can damage the eye. That means it is available with the proteins, it is available, or that is absorbed by the proteins within the lens structure, and that is used in excessive amounts that can damage the eye if more infrared and the ultraviolet lights are absorbed by the lens. And the innermost membrane of the eye is known as the retina. So when we talk about the retina, this is the retina, that is the innermost layer that is used. That lines, or this lines in the inside of the walls are entire the posterior portion that is available within the posterior portion. And when the eye is properly focused, when the eye is properly focused and light from an object outside the eye is imaged on the retina, that is imaged on the retina when the eye is properly focused. And the pattern vision is afforded by the distribution of the discrete light receptors over the surface of the retina. Now, there are two categories of receptors. One is a cones, one is a rods. And cones in the eye number between the 6 and the 7 million, and they are located in the central position of the retina, that is known as a fovea. This is known as a fovea, that is used as a central location. And humans can resolve the fine details with these cones largely because each one is connected to its own nerve end. And the muscles controlling the eye rotate the eyeball until the image of an object of interest falls on the fovea. When we talk about the cone vision, that is also known as the photopic or the bright light vision. And the number of rods is much larger, that is ranging from the 75 to 150 million that are distributed over the retinal surface. So number of rods are very much higher, that range between the, or that we can say the inches from 75 to 150 million that are distributed over the retinal surface. And the area that covers or that are connected to a single nerve and reduce the amount of the details by these receptors. So these are the receptors that receives the, we can say, the color, infrared rays, or the signal to the eye. Now, what is the role of the rods? That serves to give a general overall picture of the field of the view, and they are not included in the color vision and sensitive to the low level of the illumination. For example, when you talk about the object that appears brightly colored in the daylight, when seen by the moonlight, appears as a colorless form. So when we see in the moonlight, they appear in the colorless forms because only the rods are stimulated, and this phenomenon is known as the scotopic or the dim light vision. When the object appear brightly colored in the daylight, when seen by the moonlight, that appears as a colorless form. So when we appear in the moonlight, that appears in the colorlight forms or colorless form, that known as the dim light vision. Now, when we talk about the figure 2.2, this shows the density of the blind spot. They are the cones in the roads that is available. This is from the 0 to the 80 degree, 0 to the 80 degree. That is the degrees from the visual axis, that is center of the fovea, where the center is available, and on the left hand side it is available, right hand side it is available. Now the dotted lines are represented or can be used to represent the roads, and the cones are represented with the normal thick line. And the absence of the receptors in this area results in the so-called blind spot, and except for this reason, the distribution of the receptors is readily systematic about the fovea. When we talk about the receptor density, that is measured in the degree from the fovea, that is measured in the degree that ranges from the 0 to the 80 degree. Any we can say axis, that is in the degree of axis. That is measured with the angle that is formed by the visual axis and the line passing through the center of the lens and intersecting the retina. When I talk about the figure 2.2, that cones are most dense in the center of the retina. So this is the more dense in the center of the retina. And note that the rods increase in density from the center out to the approximately 20% of axis, and then decreases in density out to the extreme probability of the retina. This is down and increase with a 20% with a decrease in the density. Then fovea itself is a circular indentation in the retina of about 1.5 mm in the diameter. And in terms of the future discussions, talking about the square or the rectangular arrays of sensing elements is more useful when we talk about the future dimensions of future discussions, that is talking about the square or the rectangular array of the sensing elements. And based on these approximations, the number of the cones is highest acuity in the eye, that is approximately 337,000 element that is covered or that is charged with the power that is known as a CCD, that is a charge cover device that imaging the chip of the medium resolution that can have this number of elements in a receptor array that is no longer than the 5 mm into 5 mm. Now, how the image will be formed. This is the graphical view how the image will be formed between this is a graphical representation of the eye looking in a part. So just do one thing. First of all, read out this one. If there is any doubt, then please ask the doubts. Now, any doubts? Any doubts? Okay, so let's move to the next part, that is image formation or image formation in the eye. This is the example, this is the figure that shows the graphical representation of the eye looking at a palm tree, and point C is the optical center of the lens. That is from we have to see, or we have to set the optical lens in the center or optical center of the lens that is available, that is the C point, and we have to look from C point to the palm tree. So when we talk about the ordinary photographic camera, the lens has a fixed focal length and focusing at the various distances that is achieved by varying the distance between the lens and the imaging plane. So whatever the distance between the imaging planes, whatever the categories that is available with the imaging plane, that will be achieved by varying the distance between the lens and the imaging plane where the film is located. So there is the imaging plane where the film will be located over here. That is the graphical representation of the eye. And in the human eye, the converse is true because the distance between the lens and the imaging region is fixed and the focal length needed to achieve proper focus. That means this length is fixed. This is 115 meter, this is the 100 meter, this is the 17 mm. This is fixed. And that is obtained by varying the shape of the lens. And the fibers in the slurry body accomplish this filtering or thickening the lens for distant or near object respectively. That means it is available for the distinct or the near object respectively, that is used with the C point. And the distance between the center of the lens and the retina along the visual axis is approximately 17 mm. That is ours. Told you that this is approximately 17 mm, and the range of the focal length is approximately 14 to the 17 mm. And this range is between 14 to the 17 mm, and the latter taking the place where the eye is relaxed and focused with a distance greater than about 3 mm. I'm going to talk about the figure 2.3 that illustrates how to obtain the dimensions of an image that is formed on the retina. And for example, suppose that the person is looking at a tree 15-meter high. This is the example that is given. If the person is looking from the C point and the tree is 15-meter high, at a distance of the 100 meter. That means the distance is 100 meter and the height is 15 m. And let the h be the height of the that distance. That means h equals to, or that means this is generated. This is calculated with the 15 upon 100. Why? Because the h is divided by the height is divided by the, yes, height is divided by the distance. That is 15 upon 100. That is equals to the h divided by 17, or h equals to 2.55 mm. And perception then takes place by the relative excitation of the light receptors, which transforms radiant energy into the electrical impulses that ultimately are decoded by the brain. That automatically decoded by the brain. This is we can say the graphical image formation, or how the image will be formed. That the image formation in the eye. That the ordinary photographic camera, that the lens have a fixed length period and focusing on the various length procedures. Next one is the brightness, adaptation, and the discrimination. Now, what are the three terms that is used? One is the brightness, one is the adaptation, one is the discrimination. And because the digital images are displayed as a discrete set of the intensity, the eye's ability to discriminate between the different intensity level is an important consideration in presenting the image processing result. So whenever we represent the image processing result that is available, or that is able to, or that is the ability to discriminate between different intensity levels, that is one of the important consideration, one of the important factor in the presenting image processing results. Because that is used with the digital images that are displayed with the digital image as a discrete set of the intensity. And this eye ability is also used to discriminate between the different intensity level. That is also important consideration that is presentable within the image processing results. And the range of the light intensity levels to which the human visual system can adapt is enormous. That it is adapted to the enormous on an order of the, or on the order of the 10 power 10 from the scotopic threshold to the glare limit. And when we talk about the experimental evidence that indicate that the subjective brightness is a log function of the light intensity in incidence of the eye, that is available with the log term, that is used with the log term that is perceived by the human visual system. And when we